In our previous lesson on indices, we established some important facts. And one of them was the fact that indices basically refers to an easy way of expressing repeated multiplication. For example, instead of writing 2 times 2 times 2, that is multiplying 2 by itself 3 times, we prefer to write 2 to the power 3. And 2 to the power 3 is the same as 8. In that same lesson, we established the fact that the 2, for example, in this particular example we have on the screen, the 2 is known as the base, and then the 3 on top is known as the exponent or the power, which is also called the index. So this can be read as 2 to the power 3, or 2 to the exponent of what? 3, or 2 index 3. Those lessons were quite easy and understandable. So if you have not watched them yet, you can watch them before you continue with this lesson. Interestingly, along your journey or exam, you might face similar questions like this, like the one we have on the screen, where you'll be asked to solve for the unknown value, which is x. This kind of equations, that is 2 to the power x plus 1 equal 8, is known as indicial equation, or other words, equations involving indices. When we say indicial equations or equation involving indices, we are just referring to the type of equation where there is an unknown value in the index that you need to solve. And it is called an equation because of the presence of an equal to sign. Because of the equal to sign, it's called an equation. So this is an indicial equation. So how do we solve for the unknown, which is the x in this question? There are some simple steps that are involved in solving indicial equations, and we'll be using some examples to establish or rehearse those steps. Our first example is 3 to the power x equal 9. 3 to the power x equal 9. This is an indicial equation, a very simple one. What are the steps involved in solving for indicial equations? What are the steps? The first thing you need to do is to check if the value at the right and the left side, if there is something you can do to the values such that they will have the same base. For example, the number on my left is 3 to the power x. The base is 3 and the power is x. The number on my right is 9. Is there anything I can do to 9 such that it doesn't change but ends up having the same base as 3 to the power x? And the answer to that question is yes. Because we know that 9 is the same as 3 to the power 2. Why? Because 3 times 3 is 9. So the equation at the top can also be written as 3 to the power x equal 3 to the power 2. So we are done with the first step. At this level, there is nothing we can do but just to compare the exponents. So that's the next step. After we've gotten the numbers having the same base, for example, 3 to the power x is equal to 3 to the power 2, it simply means that the exponents are also the same since the bases are the same. The right-hand side, the base is 3. The left-hand side, the base is 3. Which simply means that the exponent or the index are the same. So x is equal to 2. So we are done solving for the unknown, which is x. Easy, right? Yes, it is easy. Let's pick another example that will be a little bit upgraded or much more difficult than the first. That is 9 to the power 4x equal 81. So we are going to repeat the steps again. We have on the left, or on my left, the base is 9. And on my right, the base is 81. So is there something we can do to 81 so that it will have the same base as what we have on our left? On our left, we have 9 to the power 4x. Can we change the 81 to also become 9? And the answer is yes, because 81 is the same as 9 to the power 2, because 9 times 9 is 81. So you need to do your multiplication table, right? Good. So then the equation we have at the top, that is 9 to the power 4x is equal to 81 is the same as 9 to the power 4x equal 9 squared. Now, the bases are the same. On the left and the right, the bases are all 9. So what does that mean? It simply means the exponents are the same, or 4x is the same as 2. So now we compare the exponent. Are we done? Not yet. We are solving for x, not for x. Keep that in mind. We are solving for the unknown, and the unknown is x. So we are not solving for 4x. So what do? We divide through by 4. So x now becomes 2 divided by 4. X now becomes 2 divided by 4. But this fraction, which is 2 divided by 4, is not the simplest form we can possibly have. So we need to reduce it or simplify it into 1 over 2. 2 at the top will divide itself once and divide 4 2. So x is actually 1 over 2. How can we be sure that our answer is correct? How can we be sure? So the next steps I'll be doing here are not necessary when you meet this kind of question in exams. But I just want to show you what to do if you want to be sure if your answer is correct or not. Now we have found x to be equal to 1 over 2, right? Now let's pick our question. You will see that in the original question, we have 9 to the power 4x. Now we know that x is 1 over 2. So let's replace the x with 1 over 2. So now I have 9 to the power 4 times 1 over 2. The 2 at the base of at the denominator of 1 over 2 will cancel itself once and cancel 4 2 times. So now what do we have? We have 9 to the power 2. And 9 to the power 2 is the same as 9 times 9, which gives us 81. So you can see and verify that our answer, which is 1 over 2, is actually the correct answer. Because if you put the x into the original question at the top, you realize that 9 to the power 4 times 1 over 2 will give you 81. So that's one way of verifying your answer. Okay. I think there's another question, maybe the last one. Okay. So we have 2 to the power x, bracket opens, x minus 3, bracket closes, equal 1 over 4. How do we solve this kind of question? The first step again, check the base on your left and on your right, the numbers there, and see if there is something you can actually do about the numbers. So let's see the first step. The first step is, you can see that in our question, the left-hand side, the base is 2. But on the right-hand side, the number there is a fraction. Meanwhile, the fraction has a denominator of 4. So we have converted a 4 to 2 exponent 2. There is a reason for doing that. We want the denominator to have the same base as the base on our left. You will see why we did that in a second. So 1 over 4 is the same as 1 over 2 exponent 2. What is the next thing we need to do? The next step is to change the 1 over 2 exponent 2 to 2 exponent negative 2. If you find this step so confusing, I already have a lesson on negative index law. If you have not watched that lesson yet, then maybe that is why you find this step quite confusing. But if you have watched it and still don't understand, then I think it's the time to re-watch that lesson and remind yourself of what you mean by negative index law. But as a quick recap, for negative index law, in that lesson, you would realize that we explained the fact that when you have a fraction of the form 1 over 2 exponent 2, it is the same as 2 exponent negative 2. Or if you have 2 exponent negative 2, it's the same as 1 over 2 exponent 2. We explained that in that lesson, so you can watch. So at this step, we can see that the bases are now the same. On our left and our right, the bases are all 2, which simply means that the exponents are the same. So we can compare the exponents now. The exponent on my left is x, bracket opens, x minus 3. And on my right, the exponent is negative 2. So that means the exponents are the same. But what do we do? Let's expand the exponent, the number on our left, which is x, bracket opens, x minus 3. Let's expand it. Remember, our focus is to solve for x. So at this step, all we have to do is to expand. So we'll pick the x outside and use to multiply the first x. After that, we'll use it to multiply the negative 3. So x times x will give you x squared, and x times negative 3 will give you negative 3. So this is what we will get. X squared minus 3x, x times negative 3 will get negative 3x. Yeah. So the equation we are now going to get to be x squared minus 3x equal negative 2. The x squared minus 3x is just the expanded form of x into bracket x minus 3. Now we have some equation on our hands, like some quadratic equation is kind of like forming. What do we do to solve for x? All we need to do is to move the negative 2 closer to the other terms. So it now becomes x squared minus 3x plus 2 equals 0. We move the negative 2 to the other side of the equal to sign, and now it changes to become positive. These are basic math knowledge I'm sure you already understand. Now what we have on our hands is simple quadratic equation. What do? We need to factorize the number on our left. That is x squared minus 3x plus 2. How do we factorize it? If you check the x squared, the coefficient of x squared is 1. So that coefficient of x squared, which is 1, you use it to multiply the constant term. The constant term, or the constant, is 2. Good. So 1 times 2 is 2, right? So I would have decided not to mention that step for you. So now we'll pick the constant, which is 2. We'll check the factors of 2 such that if you add them, you will get negative 3, which is the coefficient of x. And if you multiply them, you will get the constant, which is 2. Let me repeat that step. You are going to look for the factors of the constant, which is 2. Those two factors, you pick 2 factors. And those 2 factors, if you add them together, you should get negative 3. But if you multiply them, you should get positive 2. What are those 2 numbers? Those 2 numbers are obviously negative 1 and negative 2. Why? Because negative 1 plus negative 2 will give you negative 3. But negative 1 times negative 2 will give you positive 2. So we will replace the negative 3x with negative x minus 2x. So we'll just break it apart in that way. So now the number at the top now becomes x squared minus x minus 2x plus 2 equals 0. What we're actually doing is factorization. So I hope if you really understand factorization, this step should be a walk in the park. Factorization is an entire topic on its own, and that's not the focus of this lesson. So now what do we do? All we need to do is to group these terms. We have x squared minus x minus 2x plus 2. So we'll group them x squared and x as one set and negative 2x plus 2 as one set. Now we factorize them. What we will get is this: x bracket opens x minus 1 minus 2 bracket opens x minus 1 equal 0. And now if you pay close attention to the most recent equation that we have, you can see that the values or the expressions in each of the brackets is x minus 1. Since we have x minus 1 in the 2 brackets, we only pick one of them, which is x minus 1. And then the numbers we have outside the brackets are x and negative 2. We'll put the 2 also in one bracket. So x minus 1, one bracket, x minus 2 in one bracket. All of this is equal to 2. When you solve for x from this step, you realize that x is equal to 1 or 2. But you might be wondering, how did we get x to be equal to 1 or 2? Here's what is done. X minus 1 times x minus 2 is equal to 0. So all you have to do is to pick the first side, which is x minus 1, and equate it to 0. So x minus 1 is equal to 0. If x minus 1 is equal to 0, you just write them, you just move the minus 1 to the other side of the equal to sign. It becomes x equal 1. So x is equal to 1 in that side. When you are done, you now pick x minus 2 equal 0. So if x minus 2 equals 0, that means x is 2 by moving the 2 to the other side of the equal to sign. So for this particular indicial equation, we are done. That is done and that's it. You can end it here, but maybe you would like to check if our answer is correct or not. We want to check if our answer is correct or not. If you look at the original question, you have 2 to the power x, bracket opens, x minus 3. And now we are saying x is 1 or 2. So we'll first consider 1. So wherever we say x, we put 1 there. So 1 there. So it becomes 2 exponent 1, bracket opens, 1 minus 3. Now let's check what is in the bracket, 1 minus 3. 1 minus 3 is negative 2. And negative 2 times 1 outside the bracket will give you negative 2. So we now have 2 to the power negative 2. And 2 to the power negative 2 is the same as 1 over 2 to the power 2, which equates to 1 over 4. So it is clear and obvious from this step that if our x is 1, our answer is actually valid. What about if x is 2? Mind you, these steps are not necessary in your exams. I'm just using it to verify your answers for you. So if x is 2, wherever we see x, we put 2 there. But let's show what is in the brackets. 2 minus 3. 2 minus 3 is negative 1. Negative 1 times 2 gives us negative 2. So now the next value will be 2 to the power negative 2, which equates to 1 over 2 to the power 2, which is equal to 1 over 4. I hope you understand everything we've discussed so far. But if you have not understood from the beginning till now, what it basically requires of you is to just rewatch this video again. That's basically how the brain works, especially if you are not very familiar with factorization. So you see how important it is to understand the various lessons in mathematics or any other subject. The topics are interconnected. So understanding factorization makes solving indicial equations a walk in the park. So if you find this lesson helpful and you understand everything we've discussed, give it a thumbs up, share this video with other students, and don't forget to subscribe to the channel. See you in our next lesson.